Okay, so we're going to kick off. Welcome everybody to this Digital Open Day. This is the subject talk for chemistry. My name's Sandy Kilpatrick. I'm a lecturer in inorganic chemistry, and I'm also our undergraduate tutor for admissions. So yeah, welcome to the School of Chemistry and our Digital Open Day. It's really exciting to tell you a bit more about our course and what chemistry at Leicester is all about. So yeah, it's my privilege to be here with you today. My name's Sandy Kilpatrick. As I said, I'm a lecturer, I'm a researcher and teacher within the School of Chemistry, but I'm also a admissions tutor. So I'm the person to come to with any questions that you may have about the process of admissions or any questions about specifics on the course or yeah, anything whatsoever, really. So yeah, I teach inorganic chemistry, which is the chemistry of metals in molecules. It's to do with catalysts and turning greenhouse gases like carbon dioxide into useful products. So that's in the area of sustainable chemistry, which is going to be a really important part of all our future technologies. So today's program, obviously, we're not giving you any tours around the building, unfortunately, given this is Digital Open Day. But we do have, following today's talk from myself, we have one of our student ambassadors who'll be here to answer your questions. All right, so just to give you a general introduction into the background of the University of Leicester, it was founded as Leicestershire and Rutland College University in 1921. And we're the only university in Europe that was founded by its community as a living legacy to those who made sacrifices in the First World War. So this is reflected in the university's motto. Don't ask me to read out the Latin, but today, right here in 2024, we pursue excellence and knowledge and learning, and we believe that can transform our community and our world and beyond. Our fundamental belief is in education to improve our society. You might be thinking about more down-to-earth topics when you're considering your choice of universities before you, and accommodation is, of course, a big one with the cost of living and the environment that you're living in being all important to student welfare as well. So one thing that we're really pleased to offer to you today is guaranteed accommodation for all first-year students who put us as their firm offer. First choice, and we basically have a range of different accommodation options available, starting at £69 a week, including all bills, and there are lots of different options in terms of the rooms. So we have the city accommodation and we have ODB accommodation. So depending if you prefer a more centralized urban environment or a more leafy suburban environment shown there. And because chemistry is on our main campus, and for example, the village in Odeby is out in the suburbs, we have a free student shuttle bus which goes between our different sites, and yeah, that's a very nice resource to have. So both sites are available to view. If you come to one of our offer holder days, we'd be really happy to show you around these sites and see for them yourselves. But I believe there's also an accommodation talk that's happening as part of this Digital Open Day. So please check that out yourselves. Let's talk about the School of Chemistry, which is obviously why you've come here today. If you're actually interested in another subject, that's also fine. I'm happy to convince any budding biologists or archaeologists that really studying chemistry is the best thing for your future and for the next 3 or 4 years. So about us in the School of Chemistry at Leicester, we've a really strong heritage. We graduated our first students in 1927, so we're coming up to our centenary year. We've got award-winning academics in both the teaching aspects and the research aspects. And our research groups are really giving students access to cutting-edge research facilities and that research-inspired education, which is one of our main main themes. So not only is the research happening in an academic context, it's also led to numerous spin-out companies and ways of commercializing the research that happens at Leicester. And we have a satellite campus, which is in China. So I actually just got back from our campus in Dalian in China. So our degree is delivered in 2 continents via our flying faculty model. So you're part of a global community by studying at Leicester. And our degree is accredited by the Royal Society of Chemistry, which is that crucial accreditation which all the best chemistry courses have alongside them. And we have Athena Swan Silver Award for our equality, diversity and inclusion efforts. So let me just talk a little bit about research within the School of Chemistry. I mentioned before we have a world-leading and diverse research portfolio that spans these 5 topics we see in front of us. So synthesis and catalysis is the research section that I'm proud to be part of. That's the design of new molecules and applications for catalysts. That could be for making new medicines, that could be for making new energy materials, or making new agriculture or smart material type compounds. Anything that needs a catalyst is part of our research theme. We also have the Materials Centre, which is a separate building from the main School of Chemistry, where research is done into lithium-ion batteries and lots of applications more downstream in terms of the practical rollout of the chemistry. We have the Leicester Institute of Structural and Chemical Biology, so looking at the chemistry of life, and that spans into health and the design of chemicals as medicines and drugs. We then have spectroscopy, so using advanced spectroscopic tools to investigate structure and activity within molecules. And then we have really cutting edge learning and pedagogy, which obviously feeds into our teaching excellence. So we have lots of financial support from both government, charities, and also external funding. And our research is really part of how we deliver our teaching. Here's some accolades based on the university and some recent awards that we've won. So whether or not you read this publication, we're very happy to say that it's announced the University of Leicester as the University of the Year overall in 2025. It's also twice shortlisted as University of the Year by the Times and the Sunday Times in 2024 and 2025. So we are rated gold in the Teaching Excellence Framework, which is a national survey of teaching excellence and impact. So that's the highest ranking possible for any institution in the country. And so that gold standard really speaks for the quality of the teaching and education that we provide. And the National Student Survey is one of the largest of its kind. It's an exercise where you get over 300,000 responses from across the UK, where students describe their time during their studies. And we're proud to be a university producing world-class research that's also in the top 30 of the National Student Survey. So we're really proud of these accolades. Also, just in particular on that National Student Survey, we're really proud to show that the School of Chemistry was ranked 5th for overall positivity. So students are asked, final students are asked to give their overall positivity about the course. And chemistry were ranked 5th in the UK for overall positivity. So we're delighted with that result. It really demonstrates how students feel about chemistry here at Leicester. Some more key statistics about our global and national reputation. So 100% of our research in the School of Chemistry was ranked in the Research Excellence Framework, or the REF survey, as world leading research. So that's really showing that all of our research outputs, our publications, our patents are world leading. We are ranked first in the UK for student voice, and that's something that will come up again and again, that our course really gives the students themselves a voice into the topics and the style of learning and assessments throughout their degree. So we're actually ranked first of all universities in the UK for that criteria in the National Student Survey. The Guardian University Guide 2025 has ranked our School of Chemistry 9th in the UK, which we're very, very proud of that top 10 statistic. And as I mentioned previously, our School of Chemistry has an Athena Swan Silver Award for its equality, diversity and inclusion aspects, particularly around scientific women's academic networks. So why study chemistry at all? What can chemistry do for you if you are to spend the next 3 or 4 years studying chemistry at the University of Leicester? Well, for us as your lecturers and you know, for the students and postgraduates here, we believe that chemistry is incredibly exciting and fun, but it's also very important. So here you can see a number of the buzzwords that I'm sure you'll be familiar with from studying chemistry at high school, to do with atoms and electrons and elements and solutions. But really, where chemistry comes alive in your undergraduate studies is how it translates into these areas of societal importance. So medicine is at front and center here. The development of new medicines, of new vaccines, of new drugs has chemistry at the core of it. So we have many research groups and teaching modules which talk about the development of new medicines from a chemical standpoint, and how those medicines work in the body, and understanding that chemical biology. We will then also have environmental chemistry, looking at the atmosphere, how climate change is affected by chemistry. Food chemistry is a huge industry throughout the UK, looking at additives and preservatives and how many products on your supermarket shelves have chemistry development in their core. I've mentioned smart materials already, and that can be energy materials like lithium-ion batteries or photovoltaic cells, so both energy production and storage, but also smart materials, so semiconductor materials and all those kind of high-tech electronic products which are in our mobile phones and our technologies of the future. Our courses that we offer to support those different themes in chemistry broadly break down into the BSc course, which is a 3-year course, and the MChem course, which is a 4-year course. So I'll take you through the BSc course to start with, where our first option is the BSc in chemistry, F100. And then we also have medicinal chemistry. All these BSc courses have an optional additional year in industry option, which elongates that to 4 years in that case. Our MChem course is 4 years inclusive, so that is chemistry MChem as the straightforward course, F105, and then we have extra options which are a year in industry or a year abroad, or indeed our medicinal chemistry MChem. And I'll talk to you through what those different optionals mean for the courses in later slides. All of these courses are accredited by the Royal Society of Chemistry. We also have our chemistry with a foundation year BSc as an option. So undergraduate chemistry, our typical offer, excluding the foundation year, that is at BB, that's for both the BSc or MChem options. These are our typical offer grades. You can convert that into International Baccalaureate. For GCSE, we expect a maths at grade 6 or a B and above, but we are people who don't meet these grades, we're always available to discuss options going forward, and indeed with something like maths, we have a really good track record at improving outcomes and exam performance with those who didn't come into us with great maths grades. Our first year program does a lot of work improving students' basic maths to take them through the rest of the degree. So to apply to our undergraduate courses, Obviously, UCAS is your one-stop shop for applications, and you can actually take a photo or a screenshot of this slide, or pause it if you're watching back asynchronously. This telephone number will take you through to our admissions hotline, and we'll be able to answer any specific questions that you have. You can also ask us a question online via the website in front of you, and you can chat with one of our students. So there's a chat bot, but it actually gets messaged directly to one of our students who can give you a tailored response via this study/chat link. So what we really think is a highlight of chemistry at Leicester, and a highlight of our course, is that we are a friendly, fun and supportive environment to study. We put students at the heart of what we do, and that breaks down into very varied assessments, so not just exams, but also many coursework and peer assessment activities. We have technology embedded throughout our course and throughout our practical activities with state-of-the-art computing facilities. We use context-based learning, so that is really looking at those ways that chemistry interacts with society through medicine, through agriculture, through food chemistry, through materials and energy applications, and then embed that broad societal picture into our teaching on the course. So we look at the big challenges which are going to face tomorrow's scientists: climate change, drug discovery, sustainable manufacturing, energy production and energy storage, and really that context-based learning comes throughout the taught modules. We have lots of optionality embedded in the course, and because we put students' voice front and center, we have a lot of flexibility as well. And I've already told you that we're proud to be a research intensive institution, and that means that students get a chance to be part of that research environment when they join the research groups for their projects in their latter years. So in front of us, we have a schematic of a typical week at the University of Leicester as an undergraduate student. Your timetable will loosely be broken down to about 20 contact hours per week. And on top of that, we have about the same number of hours of individual study. So our core lectures around 7 hours, then optional modules around 3 hours. Laboratory work is key to a practical subject like chemistry, so we have 6 to 12 hours per week in the teaching labs, and then we expect private study, so that's guided independent learning, of about 6 hours. And those core hours decrease whilst the optionality increases as we progress through the course. So let's see how that breaks down between the BSc, that's the 3-year course, and the MChem, that's the 4-year course. So the red boxes here are core modules, and so those are largely the same for year 1 and year 2. We see that the core module component and the practical research component and the supplementary option component is the same between the MChem and BSc courses for the first 2 years. It's then in year 3 that we get a difference between them. So our BSc students will have core modules and then a research project, which is their BSc thesis, which takes place. They have 2 mini projects in semester 1 and semester 2, and then they have optional modules that they can take alongside those. For year 3 on the MChem course, the practical and research element is slightly different, where they either take an advanced practical course in our teaching labs in research techniques, or they can do the study abroad year or the year in industry, and more about that later. And then the 4th year is unique to the MChem course. So that is when students spend an entire year on a practical research project. They join a research lab. They effectively embed themselves within the research environment at the university. And alongside that, they have further optional modules in advanced courses to give them that master's level qualification. So by and large, we see that we get increased optionality as you go through the course, and the practical component ramps up from year to year. You can see additional activities shown here. So we don't just have lectures, we also have tutorials which take place. That's small group learning for students to interact with their tutors, ask any questions and get more tailored feedback. We also have workshops and problem classes, which are smaller groups as well. And then when they have career sessions with our dedicated careers service, which come to us once a week for dedicated sessions, including study skills, and that's embedded within the timetable. And our finalists, so that's a third year BSc or a fourth year MChem, will conduct an extensive independent research project, which gives them those industry relevant practical skills. So I've already mentioned our careers are very important to our course here, and the learning and support that comes from our careers team. So we have context-based learning, which really provides experience of the jobs of tomorrow and equips you with the skills to succeed within those jobs. We have weekly careers drop-ins within the department, which is embedded in the course, and that's run by our careers and employability team. And these are really great sessions. We've had great feedback from our students about those. So employability skills alongside the theory and practical, which is embedded throughout the course, with a really great careers and employability team and placement tutors, so that you really have those career skills when you graduate. And we have experience opportunities throughout the program, particularly if you do a year in industry, and we have opportunities also for summer internships, both within academic research labs, but also within industrial contacts and partners from the university. So the Careers and Employability Service, which is located in the David Wilson Library, there's a careers hub there. They have many one-to-one appointments and CV sessions, careers coaching, helping students prepare for their interviews and cover letters. There's also digital support. So, if students need a quick check on a CV before sending it out, we can do that via our AI tools. And then there are specific events that happen throughout the year, such as careers talks, careers workshops. We have many industrial leaders come to visit us in the School of Chemistry, and they run tailored sessions and answer any of your questions about a career in pharmaceutical chemistry or a career in battery technology, or we've had such events over the years. So I mentioned the year in industry as one of our flagship courses. So this is when the student spends their third year on an industrial placement. So this is for a BS for a MChem with a year in industry, although there is a BSc variant thereof. So this student, Rosie Horwood, was actually one of my personal tutees who spent a year in industry working at a chemical company in Oxfordshire, a placement with this company called Infinium, and at the end of that year, which was very successful, students are always paid for their time on placement. They will be paid for their year, and quite often that results in a job. So in the end, Rosie got offered a job with that company, and actually several other companies then started offering her jobs. So it's a great route for employability. So these are the types of companies that chemistry students have gone to work for previously. So GlaxoSmithKline, Pfizer, obviously giants of the medicinal chemistry industry. More local companies like Signature Discovery, AstraZeneca, another big player within chemistry of medicine and the life sciences. And then we have more manufacturing chemistry employers, so giants again like Unilever, who are involved in food and manufacturing. Reckitt are another employer that have taken some of our students for year in industry placements very recently. So if you want to know a bit more about that, we can put you in touch with students who've done a year in industry, and they'll be happy to share their experiences of what it was like. The next option for taking a year out is to study abroad. This is where students in their third year will go and study in one of our partner institutes around the globe. So this really provides students with an opportunity to travel and study and get used to what it's like doing a research placement abroad. So we have partner institutions in the USA, in Canada, in the European Union, so in Germany, in Spain, in Prague in the Czech Republic, in Belgium. We've got some excellent locations in the European Union. And also because of our partnership with Dalian in China, we have exchanges with China, and recently we've added Japan as well. So last year our first student went and did a year abroad in Japan. I'm also the study abroad coordinator for the school, so if you have any specific questions about that chemistry with a year abroad, I'm very happy to field those in the Q&A. What does a Leicester chemistry alumni end up doing afterwards? What do they graduate and what do they end up earning afterwards? Well, that's a really good question. I'm sure it's front and center of many parents' minds who are thinking about their children going to university. So career destinations for a chemist are both within the lab, as you might think, but not all chemists wear white coats. We have many career destinations outside of the lab. So you can see that chemical analyst, energy consultant, development chemist, these really use the expertise and knowledge that you develop through a physical science degree like chemistry, but then translate into direct applications, which are all important for the UK economy. So many of the people that I studied chemistry with, most of them have left academia or industry, but work in adjacent fields like patent law, for example, like being policy advisors, like being research managers, or working in for investment funds to do with which research they choose to invest in. And you can see that chemistry graduates really do end up in highly skilled work. So 75% of our Leicester chemistry graduates, 15 months post-graduation, end up in highly skilled work, and that salary, £65,000, is an average salary according to the University of Leicester alumni census in 2022. You can see that our graduates end up earning those top salaries in highly skilled work. And here are some of the employers. So some of them tie over with those research placements. You can see that getting a year in industry leads on to a top career and a foot on the ladder. But of course, many of our graduates go on to work, for example, in the civil service, in the National Health Service, and also in our schools and universities around the country. So basically, chemistry gives you many doors. It opens many doors, and there's a diversity of careers that you can get into from chemistry. It gives you those key numeracy skills, those key problem solving skills that all employers are keen to see. So analytical skills are also really important when we have conversations with employers, and we make sure that we give our students those employer relevant skills when they graduate. So one of the things we're most proud of in the School of Chemistry is the support that we give to students. So we mentioned that we're ranked first in the National Student Survey for student voice. How that breaks down is that our staff, both academic and technical, are here for our students at all times. So we have all students have a personal tutor, and they have weekly contact with their personal tutor to discuss any academic or personal issues that they may encounter or challenges, and that personal tutor is there for them to field any questions or put them in contact with the relevant professional. We also have lots of small group teaching, which gives us that small close-knit community. We're proud to say we give excellent support for students with learning disadvantages through our Accessibility Institute. The school adopts a universal open door policy so that staff are accessible to students, and we encourage that face-to-face dialogue as well as lots of email contact. And students, when they arrive, get a study pack to help support them to get used to undergraduate study and how that might be different from what they've done previously in school. So that's provided for free in week one. It provides a lab coat, safety specs, calculator, periodic table, molecular modelling kits, and all of the students' lecture notes are available both online and in print throughout their time studying with us. So to summarize and to wrap up, really, we encourage all of you to come and study with us in the School of Chemistry at Leicester. We believe our course is exciting and very flexible to tailor your modules towards your interests as you progress. We have these industrial and international partnerships which give you that value-added industrial experience which employers are looking for, or that international perspective which gives you something else on your CV and broadens your horizons and networks. You're taught in our school by world-leading researchers, and that boils down to research-inspired education, which is fundamentally important and brings life to our course. And the strong focus on small group teaching means that all students are supported throughout their studies, that their academics are very approachable, and that they can ask any questions or any things that they're struggling with can be dealt with in a small group focus. We have an excellent support structure, as I said, through our personal tuition and also our careers support, and we have excellent student satisfaction as a result of all these things, and that's borne out in our National Student Survey data. And once you graduate from the School of Chemistry at Leicester, you have excellent graduate prospects going into those high-earning and highly skilled jobs within the UK economy and beyond. So finally, this is the final slide from me. So if you want to get in contact with us, please do shoot an email to chemadmiss@leicester.ac.uk. That will find its way towards myself as the tutor for admissions, and we'll get back to you with any further questions you might have. You can also go via our central website, so le.ac.uk/chemistry. You'll be able to explore some bit more about the research and topics that I've talked to you today, and a bit more about the course structure and the modularity and options which might suit you. We're also on all of the socials, of course, so you can follow us on Instagram, on Twitter, now X, and on Facebook at Leicester Chem, where we post what we've been up to every now and again, and give you a bit more about our latest research and teaching activities. And if you want to chat with any of our students to ask a question that doesn't come up today, please do go on this website, and your questions will go to one of our student ambassadors for them to answer. So please take a screenshot of this slide if you haven't already. Anyway, that's all for me, and I'm happy to answer any questions. Thanks.
Awesome, thank you so much. That was really useful. Some really great information there. So we've not had any questions come through from the Q&A just yet, but I know we've got, say, Colin in the call as well as a current student. So Colin, if you want to maybe pop on for a minute, kind of talk about your journey with chemistry, any advice you have for kind of prospective students, and kind of like what your typical week looks like as well.
Yeah, absolutely. So I'm currently a fourth year studying pharmaceutical chemistry, now known as medicinal chemistry, at Leicester. So if I bring it back to first year, a typical week for me included about 4 to 6 hours of labs on, I think it's Friday now, and also about, like it said in the lecture slides, about 7 hours of core lecture material with some workshops on top of that. So throughout my time at Leicester, I've found it really helpful that there's been an open door policy, and also with the small classes, I've really gotten to get to know my lecturers, and it makes you feel very easy if you've got a problem that you can come speak to them, and everyone's really lovely. It's more like a community than a school feel in college and stuff. It feels a bit more formal, whereas at university at Leicester, I feel like it's very informal. I'll pass by a lecturer in the corridor and ask how their weekend was, and it's just like a very nice feeling. And yeah, I struggled quite a bit with science during college and secondary school, but coming to Leicester really made the actual scientific knowledge very accessible with the printed out notes and the way they actually break down the information. That's something that really helped me and helped me transition to university and to having better knowledge. I'd also like to say that compared to different cohorts at different places, they take a lot of students. And so I know a lot of friends at other universities, they share fume hoods and stuff. That was never an issue at Leicester. Like, they have plenty of space to accommodate so students can have their own fume hoods, run their own experiments, and really get that independence in the research lab as well. And yeah, I just feel like it's been really engaging, and the student support is like really good here, like unmatched compared to like what I've heard from other places, and it's definitely been a standout point during my time at Leicester.
Awesome, thank you. That's really nice. I think it's always nice to hear the student perspective, and nice you've had such a good experience. I was going to ask as well, in terms of, so for the people watching, kind of prospective students, what advice would you give us, someone who's done that journey from kind of say school and college to university? What things can they be doing now, kind of on the cusp of going to university? What kind of activities, things would you recommend they be doing?
So it's quite difficult. Like I said, coming to university, I feel like just as long as you're doing something passionate, if you're passionate about chemistry, the transition will be easy. It's not like when I went to college, I found it super like, whoa, this is a big jump. But the transition I found from college to university was really accessible. I think maybe come in with a bit of an idea of the types of stuff you want, but you don't really need to develop that until after like your first, second year, where you'll really find some interest in the core parts of chemistry. So I'd say just be open-minded, sort of make sure you're passionate about the subject and that you're driven and you're interested. But I feel like the development comes after the first year, because there'll be parts in modules that will be like really stand out to you and really inspire you, and that's when you sort of delve in and sort of look into the experiences you can go and gaining experience maybe at companies in this part that you were really interested in. But I think to begin with, it's just keeping an open mind, making sure you're passionate, and yeah, not locking yourself out to like a certain part straight away.
No, that's great. That's really good advice. Something I wish I'd heard when I was in sixth form. But kind of question for both of you, really. So in terms of, so when I go out about to fairs, we get students asking a lot about kind of years in industry and stuff. Do you have advice that you give to kind of prospective students about year in industry? What kind of support we offer, and kind of the places? I know you obviously mentioned in the presentation that students have gone for those years in industry.
Yeah, if I kick off on that one, it can seem actually quite daunting when so the application for the year in industry begins in second year to then spend the third year out in industry, or indeed in abroad with one of our partner institutes abroad. And it is like a job application. There'll be industry placements which are posted on a forum, and then students have to prepare for the first time perhaps that cover letter, that CV, and apply. Just like with jobs, probably several of them, because you probably won't get the first one first time. So what support we provide is tailoring that CV and that cover letter so it matches the job and matches the skills that the student has already developed in their first 2 years of study with us. So they can say, yeah, I know what your company does, and I've actually already done something that relates to what you do, because all of our placements are scientific placements. They will be doing some element of experimental chemistry within that placement. So we can really quite nicely match and say like, oh, you use that technique, and we've actually already done that in our teaching labs. So we help prepare for that. Also, just finding the opportunities themselves. Perhaps that could just be through the extensive network that we've built up through the years of running that year in industry course. We know the specific employers that really like Leicester students, and so when they have a new opportunity, we hear about it first. And as you know, if you're first to hear about these kind of opportunities, you stand an extra chance of getting ahead of the rest on them, because they are competitive processes. So those are some of the ways in which we really help students identify those placements and then make their applications as strong as possible.
So thank you. I think that's really great advice. So I've finished my questions now. There's nothing else for me, but either of you have anything else you wanted to add in terms of advice for students? Anything else you want to say about kind of chemistry at Leicester at all before we wrap up?
Yeah, I think Colin raised some really good points there when he was talking about what to kind of mindset to go from transitioning from the sixth form and school type knowledge to more university type experience. And I think what I really liked Colin emphasized that this is where the curiosity aspect of it can start being nurtured and start growing. Don't see this as another step of school where that you've just got going to be spoon-fed knowledge that you have to learn against your will. This is the point where you kind of can cultivate a genuine curiosity and passion for the subject. And then what Colin said about keeping an open mind, that you might come in and think, I really want a career in the pharmaceutical industry at the end of these 3 years. And then you might, through studying a module in atmospheric chemistry, suddenly think that, you want to be involved in climate change and addressing climate issues through a chemistry degree. Keeping that flexibility in mind and that actually chemistry as essential science feeds into so many different aspects of the economy and society that actually you're going to be very well prepared for any of those.
Awesome, thank you. Colin, do you have anything else you'd like to add?
No, I feel like Sandy's covered most of it. Just emphasising, keep an open mind, and coming to university, it's not like school. It's going to be, everyone treats you like an adult. It's more of a community atmosphere rather than, you've got to do this, do that. It's much more of a nicer feel. And like Sandy said, it's where the curiosity starts to come, and you should see it as a way to build your knowledge and sort of invest your time in what you're curious and what you enjoy.
Absolutely great advice. As someone else who's been to university can definitely echo that. So I've just put kind of some more links in the chat. So thank you everyone so much for joining us today. I say it's been a really great session, really informative. So thank you both for joining us and for all your information. So we'll wrap up now, but thank you all so much for joining and have a lovely evening.
Thank you very much. Thanks
Thank
very
you.
much, both of you. And get in touch with any questions via the channels that I put up on the slide.